Hi, this is Nimla Ratnam. In this video, we are going to start the topic Introduction to Graphs, which is the 13th chapter from NCERT textbook class 8. This also happens to be the last chapter from the textbook. So with this, we will complete the syllabus, that is all the 13 chapters from NCERT textbook of class 8. Now here, if you remember in the fourth chapter, data handling, we looked at how to represent the data in the form of a pictograph or in the form of a bar graph or a double bar graph or a pie chart. We also discussed the significance and the importance of doing so. The purpose, why do we have to represent the given data in the form of a graph? We have realized that it is easier, it is very handy and very helpful in analyzing the given data when you represent it in the form of a graph. It will help you in comparing two quantities, it will help you in predicting the future from the given data once you have it all in the form of a graph. Now here in this chapter, we are going to look at a line graph, right? So let's quickly recap what we have already learned in this graphical representation. So right now we are dealing with the 13th chapter, Introduction to Graphs. Right? And like I said earlier, we have already dealt with graphs and data handling. So we are already familiar with a little bit of it. So we have done pictograph. We looked at few examples, didn't go into too much detail because it's very basic and very elementary. Next, we looked at bar graphs. Also, we have looked at double bar graphs. Usually double bar graphs are used when you're doing some kind of comparison between two companies or 2 years or two different schools or two different brands and so on. Then we looked at circle graph or pie chart, right? When we want to look at part as a whole, how much is the, each category percentage, by how much it is occupying as part of a whole, then pie chart is very helpful. Now here in this chapter, we are going to look at something called line graph, right? So usually when something is related to time, okay, the data, you're looking at data where you are interested in the variation of a quantity or a parameter with respect to time. Usually when it is with respect to time, you look at a line graph. So you're already very familiar with these line graphs. You've seen a lot of it being used in sports, in cricket. Whenever you're watching cricket on TV, you know that they use line graph to compare the previous team's performance with the current batting team, or the performance of different players over the different matches and so on, or performance of the two teams over you can see that that is time dependent. So usually what you use there is a line graph. So what happens in this line graph, as you know, as we already discussed, in any graph, in order to represent data in the form of a graph, first you're going to decide what is on my x-axis and then what is on my y-axis. So this is the first step. You're going to decide what's on my x-axis, what's on my y-axis, and clearly mention the units in brackets, right? And the second thing you're going to do is the scale. You're going to decide the scale. That is, for x-axis, so you have these demarcations, right? Each unit, again, you'll have small 10 parts that it's divided into, right? So each one unit is what? In specifically what on your x-axis, you're going to mention it here, and each unit on y-axis is what is it that you're taking. For example, if it is temperature degree centigrade, so 1 unit is 1 degree centigrade or 2 degree centigrade, whatever it is, you have to mention it in the scale on the top right corner of your graph. Now having done that, the third step, right, is actually plotting the points. So for each corresponding x over here, whatever is the value, you're going to look at the value of it on y-axis and you're going to plot the points, right? You will be plotting the points for a line graph. Now the fourth step is you're going to join them. right? So clearly there will be ups and downs in the y-axis, but x-axis is progressive because usually this is time. Okay, so after, for example, if it's 8 a.m. here, 9 a.m. is naturally going to be to the right of it. So there's no problem in joining the points. There's no confusion over here. You have to simply keep going towards your right, whether it's up or down. You keep going to the right, keep joining the points. You have your line graph. So this is nothing but a line graph. Now here in the second exercise, we are going to look at a specific subset of this, that is linear graph. Okay, now what is this linear graph? In a linear graph, what we do is, once you have joined these points, you will notice, you will realize that it is a straight line. So if it is a straight line, then you call it a linear. The line graph that you have got is a linear graph. Now, why is it so special? Why is it so important? The dependence of your y variable with your x variable is linear if your line is a linear graph. So if you happen to get a linear graph, then you can conclude that whatever you have represented on y-axis, for example, you have distance and time. You know that distance by times is equal to speed, which is constant. If the speed is constant, then you are going to get a linear graph, and you can say that speed is equal to distance by time. Right? So that is how your conclusion that the given line graph is a linear graph is going to be helpful to you. If it is not linear, clearly they are not directly proportional as you have it for distance and time. It is going to be something else. The relation is going to be something else. It is not going to be linear. That is the conclusion that we draw. So that you're going to have in the second exercise. So that is all we have in this chapter. So let's look at the problems. So here in the first exercise, we can see that in the first question, they have given a graph of time, temperature versus time. Okay, on the x-axis I have time, and on the y-axis you have temperature. Now here you can notice that there's something over here. Okay, this is nothing but a broken line. Okay, this over here that we have, this is a broken line. Okay, now what does it signify, the broken line? The broken line signifies this right over here, signifies that you're not starting from the first point or initial this thing, but you will be starting relevant to your data available. For example, you will see that your data, none of it is going to be below 34 degrees centigrade, because this is the temperature of a human being, right? So you will start right away from 34. Otherwise your graph is going to look very awkward. That is, you have a graph starting from 0 degrees over here, and then you will see that your data is somewhere over here, and this entire space from 0 to 34 is going to be empty, and it is quite meaningless to have it that way, right? So you're going to avoid this, and you're not going to have any demarcation from 1 to 34 by axis. Straight away I'm going to start from 34, right? So that is the purpose of this broken line. So if you simply put the broken line, you're going to start from 34, and from now on you will say that each 2 units over here are representing 1 degree centigrade. 2 units here is equal to 1 degree centigrade, right? So that is your y-axis. On x-axis as well, you will see that 2 units is 1 hour. Okay, here also you have 2 units is equal to 1 hour. So that will be your scale. Now let's look at the questions they are asking. What was the patient's temperature at 1 p.m.? So here you can see from the graph that at 1 p.m., this is 1 p.m., right? You will see that the temperature is this particular point, and this is exactly the midpoint of 36 and 37. So the answer is going to be 36.5 degrees centigrade, right? So that is your answer. Next question, when was the patient's temperature? 38.5. Now you can see that 38.5 is this particular point over here. So you will see that this is the temperature 38.5. So the time corresponding time you can see is 12 noon. Right? Next, the third question, the patient's temperature was the same 2 times during the period given. What were those times? Now you can see that the patient's temperature is varying, and you will see that it is flat from 1 p.m. to 2 p.m. If you see, the temperature is flat. That is, at 1 p.m. also it is 36.5 and 2 p.m. also it is 36.5, right? So you can say that between 1 p.m. and 2 p.m. the temperature is the same, right? Now here, of course, when you're doing a line graph, you have only limited points, and when you're joining and you have a line, there are infinite points between those two, and you're assuming here this is just we actually don't have data of what the temperature is at 1:30, or we are not taking the temperature at every infinitesimal second and continuously, but you're assuming that you're making a decent assumption that because at 1 p.m. it is 36.5 and 2 p.m. is 36.5, it is very likely that within 1 hour it did not really go up or down in this particular 1 hour, and we are assuming it is the same, right? So patient's temperature was the same 2 times during the period, which is 1 p.m. and 2 p.m. Now here, for 1:30, like I said, I'm assuming that you are not going to see a person's temperature really dropping up very high and coming back to 36.5, or going down and then coming back to 30. You're assuming, we are making a very reasonable assumption that it is most probably going to remain 36.5 during this entire 1 hour, which is 1 p.m. to 2 p.m. So that is your answer for the D bit. During which periods did the patient's temperature show an upward trend? So here you can see that from 9 a.m. to 10 a.m. it's an upward trend, right? So that is one upward trend, 9 a.m. to 10 a.m. And then you'll see that 10 to 11 also is an upward trend. Okay, very steep, right? So 10 a.m. to 11 a.m. you have a upward trend, and then from 11 to 12 it's decreasing, 12 to 2 12 to 1 it's decreasing, 1 to 2 it is the same, and then you'll see that 2 to 3 it is again increasing. So 2 p.m. to 3 p.m. So if you were a doctor, you're going to look at this, and then you'll see when was the medication given and try to correlate. Maybe once the medication was given, maybe at 11 a.m. or maybe it was given at 10:30 or 10 and it started working at 11 a.m. and the temperature is dropping. The patient was doing well from 11 a.m. to 2 p.m. right? That is for 3 hours. He seems to be fine with the temperature dropping and stabilizing. And then again, maybe the effect of the medicine is going down and the temperature is again going up. So that is the kind of analysis that you can do when you have the given data in the form of a line graph, right? So this is about the first question. Let's look at the second question. Here I have yearly sales figures of a manufacturing company. You can see that the x-axis represents the year starting 2002 to 2006, and the sales are given in crore rupees on the y-axis. Okay, so clearly here 1 unit is 1 crore on the y-axis, and on the x-axis you have 3 units is 1. Here 3 units I have 1 year, right? So that is your y-axis. That is your x-axis. 3 units over here is going to give you 1 year, right? So what is the question here? What were the sales in 2002? In 2002, the sales were 4 crores, okay, 4 crore rupees. And in 2006, the sales was, this is 2002, and 2006 you can see it is 8 crore rupees, right? And what were the sales in 2003? 2003 is over here. So you can see that it is 7 crore rupees. And then they're asking 2005. 2005 you can see is this particular point, which is 10 crore rupees. Okay. 2005, the answer in the key is given as 8.5 crore, but that is wrong. Somehow, I think they have taken this point, which is not corresponding to 2005. This is the point corresponding to 2005, which is going to give you 10 crores as the answer. Okay. So that is your B bit. C, compute the difference between the sales in 2002 and 2006. So here it is 4 and 2006 it is 2006 you have 8, right? So 8 minus 4 is nothing but crores, of course, is nothing but 4 crores. So the answer is 4 crores, right? And then the D bit you have, in which year was there the greatest difference between the sales as compared to the previous year? So for that, let us look at the difference for all the years: 2003, 2004, 5 and 6. So you can see that for 2003 it is 7 minus 4, which is 3 crores. 2004 it has decreased, so but still let's look at the difference. It is the 7 minus 6, which is 1 crore, and 2005 as compared to 2004, 10 minus 6, which is 4 crores, and 2006 is 8 minus 10, which is 2 crores. With this is a decrease, this is an increase, again this is decrease and this is increase. So you'll see that the maximum difference is 4 crores, right, which is in 2005. So the answer is 2005. So that is about your second question. In the third question, they are giving us data of the growth of two plants, plant A and plant B, which are grown in a laboratory conditions for 3 weeks. Okay. So at the end of each week, they are looking at the height of the plant in centimeters. So you have two lines here. Okay. The dotted line corresponds to plant A and the solid line corresponds to plant B. So let's look at the questions. How high was plant A after 2 weeks? After 2 weeks, plant A was clearly 7. This is the point I'm interested in. So that is nothing but 7 centimeters, right? So the answer is 7 centimeters, right? And after 3 weeks, it is going to be, plant A is the dotted line. So this is the point, which is nothing but 9 centimeters. This point corresponds to this particular point here, 9 centimeters. So in the B bit, they're asking the same questions for plant B. Plant B is the same as the plant A in the end of second week, which is 7 centimeters. However, in the end of third week, it is 10 centimeters. It has grown taller than plant A at the end of 3 weeks, right? And this is the B bit. And the C bit, how much did plant A grow during the third week? So during the third week, plant A has gone from 7 to 9 centimeters. So it has grown by 2 centimeters, right? And in the D bit, they're asking the same for plant B. From end of second week to end of third week is the same as the duration of third week. So here it is 3 centimeters. 7 to 10 is 3 centimeters of growth. Next I have during which week did plant A grow the most? So plant A, if you can see, the first week the growth was 0 to 2, which is 2 centimeters. And in the second week, you can see that it has grown from 2 centimeters to 7, which is 5 centimeters growth. And in the third week, it has grown from 7 centimeters to 9 centimeters, which is 2 centimeters growth. So the maximum that it has grown is in the second week. This is for plant A. How about plant B? They're asking the same analysis for plant B. The plant B has grown only 1 centimeter. I'm going to write plant B here. Only 1 centimeter in the first week, right? And it has grown from 1 to 7, which is 6 centimeters in the second week. Okay. And it has grown from 7 to 10, that is 3 centimeters in the third week. So the question is, growth is least. The least growth is 1 centimeter, which is in the first week. So the answer for the F bit is first week, right? And then the next question they're asking, were the two plants of the same height during any week show? Clearly, at the end of the second week, you have the same height for both the plants, okay? And specify it, it is the end of the second week. So with this, we complete the third question. Next, let's look at the fourth question. The following graph shows the temperature forecast and the actual forecast. So they're going to look at the forecast. You know that you always have a weather forecast depending on the data already available, and then you can always plot the actual temperature, after that day is over, right? So they're comparing how the forecast and the actual values are, how close or how far away they are from each other. So on which days was the forecast the same as actual? You can clearly see that for this point and this point, the forecast, and also this one, the forecast is same as the actual. So these points are nothing but corresponding to Tuesday, Friday and Sunday. So these are the 3 days when forecast and actual temperatures are one and the same. Next, what was the maximum forecast temperature during the week? So in the week, the forecast is the dotted line. So you can see that the maximum forecast was 35 degrees, which was on the Sunday. So what was the maximum forecast? 35 degrees Celsius. Next, you have minimum actual temperature. Actual is a solid line. Okay, so you can see that the solid line is dropping to the minimum over here from Thursday to Friday, which is nothing but 15 degrees Celsius. So that is your minimum temperature. Next, on which day did the actual temperature differ most from the forecast? So you have to look at the gap. So you can see that for Monday, the gap is 15 to, you can see that the gap is only 1 unit over here, right? And you can see the Tuesday there's no gap, and on Wednesday there is a gap of 2 units, right? And on Thursday there's a gap of 3 units, and on Friday there's no gap, on Saturday 2 units, and on Sunday there's no gap. So the maximum gap is on the day Thursday, right? So this was the day when the forecast varied very much compared to the actual temperature. So that is your fourth question. Coming to the fifth question, use the tables to draw line graphs, not linear graphs. We are looking at line graphs. Maybe the graphs do turn out to be linear, okay, but we cannot conclude that unless you actually have the graph with you, right? So we are looking at line graphs, okay. Let us draw the line graphs for these two particular data. Let's look at the first one first. So I have a graph paper here. First, I'm going to decide what is on my x-axis and what is on my y-axis. Clearly, years on x-axis, days on y-axis. The number of days a hillside city received snow in different years. So I have 4 years, 2003, 2004, 2005 and 2006, right? So let us write down define the x-axis and y-axis. So as you can see here, I have put a small markings after each 10 lines. Actually, in your graph paper, you will have a much clear way of, where to, there will be thick lines, clear thick lines after every 10 lines. And I've taken a very big, gap between each two lines because so that it will be very clear to you on screen. So now here, my x-axis is year and my y-axis is days. Okay. Not very easy to write in this direction for me. So this is my days, right? And after looking at the data, you need to decide what you'll take 1 unit as for your scale over here, right? So since I have 4 years, I'm taking each unit as 1 year: 2003, 2004, 2005, and 2006. That's all the data that I have. So I'll stop there. Next on this is my x-axis. This is my y-axis, right? And on x-axis, I have data varying from least is 5 and the highest is 12, 5 to 12. So here I can see that if I take each unit as 1 day, if I and then start with 5, 5, 6, 7, 8, 9, 10, 11, 12, it's going to be sufficient for me. However, for you on the graph, it will be different. So you have to decide, because if you take one unit as 1 day, your graph is going to look very, very tiny for you. So you have to take your scale accordingly, so that the graph, once you draw the graph, it looks proportionately decent and it's not too tiny or too large that the data doesn't fit in one graph sheet. Okay, that's how you're going to choose your scale. So here I have for x-axis, 1 unit is equal to 1 year, and my y-axis, in my graph, I have 1 unit is equal to 1 day. Your graph, it most probably, it's definitely going to vary. You will have many units, like you might take 3, depending on how many blocks you have on the on your side, the longer side of the graph sheet. You can take 2 or 3 units for your y-axis as 1 day. Now let's plot the points. That is the next step. 2003, I have 8 days. So if you go along this 2003, along this line, this is my, so this is 2003, right? This is the point we are talking about. Okay, so this is my first point. The second point, 2004, is 10. Okay, I'm going to go along 2004, and 10 is over here. So this is my point. This is my second point, right? And then 2005, the data says 5. So 5 is very close, so it's easy for me to plot that. This is my third point. Okay. Next is 2006, which is 12. Okay. So I'm going to go very carefully. You can use a scale in order to make sure that you don't miss. And like I said, your bold lines are very easier to follow. My line is a bit tricky. So I think this is the point we're talking about, 2006. So let me double check that. Yes, that is my fourth point. So the next step is I'm going to join these lines. Let us see. You will be using a pencil and a scale. So your lines are going to look much prettier. I'm using a free hand here. Okay. No, it's not working. Right, freehand is not working. So let us use the line segment. So here I'm joining the first point with the second point, right? So that is the first line. And then let's continue, join the second point to the third point over here. That's it. That is the data of 2005. Okay. And then I'm going to join the fourth point to the third point over here. So this is how your graph is going to look like, right? So that is all they asked us to do. Use a table below to draw the line graph. So this is your first bit. In the second bit, I have population of men and women in the village in different years. Now here you will see that you have two different data on your y-axis, right? On your x-axis, you have the year, just like before. But on y-axis, I have data from two different years. So let us see. Let us look at the data and draw the table. Sorry, draw the graph. So like in the previous sum, First, we are going to define the x-axis, y-axis. X-axis is clearly the year. Y-axis, you have number of men or women, and you will be having two lines. One is for men, one for women. So you will clearly mention the dotted line and the solid line, which one is for whom, right? And then you will decide the scale. So here, while deciding the scale, x-axis is very easy, like 1 unit you will take as 1 year, and I have 4 years, 2003 to 2007, so that's not an issue. If you look at the y-axis data, it is varying from 11, the least here is 11.3, so you'll have to take from 11, right, to it is going to 13.5, so 11 to 14, let us say. So when you have data from 11 to 14, okay, and if you take 1 unit as you know 1000, because here the population is in thousands, it's going to again look, you'll be using in on the y-axis, you'll be using only 11 to 14, which is 3 to 4 blocks. So you have to be a little magnanimous. You try to stretch your y-axis a little bit and take 2, 3, or how many of the blocks you think is appropriate, because you will be starting with 11. It's going to be a broken line. You're starting with 11 and you will end at 14, right? So let me define. This is my x-axis. This is my y-axis. So x-axis I have year. On y-axis I have number of men, so I have number of men or women, right, and in thousands. Okay, so you have to mention that you have them in thousands, right? So then I'm going to mention the scale. So x-axis I have 1 unit is equal to 1 year, right? On y-axis you have to first decide and then you'll write. So like I said, because it is only 4 that you're using and my units are pretty big, you might have 4 units or 5 units for 1000. I'm going to take 2 units for 1000. Okay, I'll take 2 units as 1000, right? So now let me do the markings. There you go. So now I'm going to write the years here for x-axis: 2003, 2004, 2005, 2006 and 2007, right? And for x-axis, I'm going to start with 11 over here. Okay, it's a broken line here. So I have 11 here, and after 2 units, I'll take 12. Okay, and then 13 and then 14. Okay, so 20 lines per 1000 you have, right? So let us look at the data for men. For in 2003, I have 12,000. Okay, that's the population, right? So that's it. That is your first point. In 2004, you have 12.5. So exactly midpoint of these two is this point. This is your 12.5. So for 2004, I'm going to go all the way up to this point. Okay, and 2005 is 13. So here I have, this is my 2005 data. 2006 is 13.2. Now what is that? Like I said, you have 20 lines for each unit, right? So from 13, so this is going to be 13.1, 0.2, 0.3, so on up to 14. So you have from 13 to 14, You have 20 such lines. So point 1 is going to be 2 lines from here. Okay, point 2, point 3, point 4, point 5, and so on. So when I say 13.2, I'm talking about this particular point. Okay, so 2006 is corresponding to this particular point. So I have 2006 is over here, correct? So this is my 2006 date. Next 2007, I have 13.5, another 5 lines from here. Okay, I have to go to, this is 13.2, 3, 4, 5. So this is my point. Okay, this is 2007. Now here I have to join these lines in order to get my line graph. Join these points in order to get my line graph. So I'm going to start that. First I have this, okay, and then join this, and then I'm going to join this, and I'm going to join this. So this is my line graph for number of men. So you can see that from 3 to 5, it's a straight line, that is, it's a linear graph. And then it is a little bit bent to either, towards right or towards the left. Now let us move on to the women population data. So for 2003, I have 11.3. So here, this is 11, this is every 2 blocks is a 0.1. So this is 11.1, this is 11.2, and this is 11.3. Okay, so this is my first point. 11.9, next point is 11.9 for 2004. So that is 2 you have to go all the way to 12 and come down 2 lines. Okay, so that is your 11.9. This is your 11.9, right? So that is 2004 data. Next I have 13 for 2005. So this is my 2005 line. So 13 is over here, all the way over here. So this is my 13. It's already marked for men. Next I have 13.2. So 2006 is over here, and this is already 13.2, and I have to go to 13.6. So 0.3, 0.4, 0.5, and 0.6. This is my point. Okay, this is the point I'm talking about, right? That is 13.6. Right. Next I have 12.8. Okay, so all the way down, it's really come down, the population of women in 2007, it's come down to 12.8. Okay, so if I can locate 13, 2 lines down of that, 4 lines, right? So this is 13 for me, this is 0.9, 12.9, this is 12.8. So that's it, this is my data. Now I have to join these lines in order to get my line graph. I'm going to use a different color. What you will be doing is you will be using dotted lines. Okay, so let's join these points. 2003 to 2004 data, right? And then 2004 to 2005, 2005 to 2006, 2006 to 2007. Okay, so you can see that looking at this data, there is a lot of analysis that can be done from this data. So here you will be mentioning clearly that in my case, the black line represents, okay, the red line represents the women data, women population, and the black line represents men, population of men. So like that, you have to mention clearly. This is men, right? So this is the 5th question. Now let's look at the 6th question. A courier person cycles from a town to a neighboring suburban area and to deliver a parcel. Okay, and they have given the graph of the distance covered and the time taken. So clearly he's starting at 8 a.m. and he is covering a certain amount of distance. What is the scale taken for the time axis? Now they're asking us what is the scale. So you can see that you have 4 blocks here, and for 4 blocks he is going duration of 1 hour, right? So 4 units is 1 hour. That is my scale, right? How much time did the person take to travel? Now you can see that he's been traveling from 8 a.m. to 8 a.m. to 11:30. Okay, this point is not 12, it's 11:30. So that is nothing but 3.5 hours. How far is the place of the merchant from the town? So he's clearly covered a distance of 22 kilometers. So the answer is 22 kilometers is the total distance. And did the person stop on his way? You can see that from 10 to 10:30. Okay, here he hasn't covered any distance. That means he has taken a little bit of, he has just stopped there. He did not travel, he did not progress from 10 to 10:30. So yes, and it is between 10 a.m. to 10:30 a.m. For half an hour he probably took a rest. Next, during which period did he ride fastest? So now that is about speed. Okay, that is in 1 hour how much distance is he covering. So let us look at that. From 8 a.m. to 9 a.m. he has covered a distance of 10 kilometers. From 9 to 10 he has covered a distance of 6 kilometers. 10 to 11 he has covered a distance of at 11 a.m. it is over here. Okay, so it is around you can say 16 to a little over um, a little over 2 kilometers, maybe 2.5 kilometers, and from 11 to 11:30 it's just half an hour. So you can see that from 10:30 to 11:30 it is the same speed at which is traveling. So 10:30 to 11:30, okay, in this period 10:30 to 11:30 he has gone from 16 to 22, which is nothing but 6 kilometers. So this is 6 kilometers. So if you see per hour, okay, you will see that in the first 1 hour he has traveled maximum distance. Okay, so the answer is between 8 a.m. and 9 a.m. he has traveled the maximum distance, which is 10 kilometers, right? So that is your 6th question. Let's go to the 7th question. Can there be a temperature time graph as follows? Justify your answer. Let's look at the first one. You will see that here you have temperature, which is on the y-axis, is increasing as time progresses. This is possible, right? If you look at the second one, as time progresses, the temperature is decreasing. That is also possible. The first one is heating process, the second one is cooling process. If you look at the third one, you have at one particular time, okay, this particular time, the temperature of a certain entity is having infinite values. Now that is not possible, right? So 3 is definitely not possible. If you look at the fourth one, as time progresses, the temperature remains constant. Now that is possible, right? So the temperature can be the same without increasing or decreasing as time progresses. So that is also possible. So of the 4 graphs, third graph is not possible. That is, any particular entity cannot have infinite values of temperatures at a given point of time. So this is all we have in the first exercise. So in the next video, we will be covering 13.2 where you have linear graphs. They are asking us to draw a few graphs, and there are 2 sums in the second exercise. Let us do that in the next video.